All right, this is our second video. It picks up in our Unit 2 linear regression notes right here with residuals and residual plots. So when we do linear regression, we create a model that is a line that models our data. All right, so if we look at a residual, what the residual is, it's the vertical distance that your point is off that line. Okay, when we go through the examples in Stapplet, I will kind of give you a visual better of what a residual looks like. You can have a single residual, which is how far off a single point is from your regression line. You could graph all the residuals at one time with a residual plot. On a residual plot, what you want, if you could picture that this is your regression line, you want points scattered around it. Okay, you want them random looking like this one. This shows a good linear model. If your points curve around the line that you've created, that means that your line is better suited to a curve, and we do not have a good linear model. Okay. You can look at the dot plot for your residuals. All we're really worried about on those is if I have a situation where I have values that are really far off my regression line. All right, so let's talk about this least squares regression line. So this is the line that most closely fits your data. So when we look at scattered points and we make a line that models our data the best, we're trying to get essentially a line that says, okay, this data most closely fits, or this regression line most closely fits the data that you've given me. Now, this line's going to come in the form of a predicted value, a y-intercept, and a slope multiplied by x, okay? And it's going to come in that order out of Stapplet, right? When you write your regression equation, make sure that you take the x and y themselves out and put the actual variable names in. When we go through the examples, I'll talk about that more. So the two values in here, the y-intercept and the slope. When you interpret the y-intercept is the value of y that you expect when x is 0. I gave you a handy little canned phrase that you can substitute in here. Feel free to use that. I want you, though, to understand what you're talking about, I hope. But if you're stuck with, I don't really understand this canned phrase can help you get through the statements we're looking for and help develop that understanding. You have another idea of another canned phrase right here that talks about how that you interpret slope. The slope is how much change you expect in y every time x increases by 1. All right, so when we look at slope, we're looking at an increase or a decrease depending on whether the line goes up or down from right to left. All right, so Stapplet's also going to give you a value of s, which is the standard deviation of the residuals. I'm mainly talking to you about this because I don't want you to confuse s for slope. S is not the slope, okay? It is the amount of variability we expect around the regression line, okay? The larger this is, the less tightly the points fit the line. R squared is the coefficient of determination. You have another phrase right here that you can use to interpret R squared. R squared is one of the hardest things that we talk about to understand. It talks about the percent of variability that our model explains around your regression line. So if R is at 100%, we have a perfect relationship. The model explains 100% of our predictions. As R squared goes down from 100% or 1, then we have less control and more variability around the line. Finally, making a prediction. When you go to make a prediction, this is something, unfortunately, that Stapplet will not do. So you have to use the regression equation that you've created and substitute the number you're looking to predict for into the equation. And you'll see this some in the examples, but you're going to need a calculator to do this part. All right, This is your second part of your video.